A variety of carboxylic acids, carboxylate salts, and esters have been known and applied by mankind for a very long time, much predating the use of IUPAC nomenclature. As a result, in addition to the systematic IUPAC nomenclature that we have used in prior videos to describe these molecules, they also in many cases go by their common names, such as the compound Methyl Salicylate, that is a common flavor and fragrance. And so in this video, what we're going to focus on are what common names you should recognize and identify with regards to these different molecules. In the case of carboxylic acids, short-chain carboxylic acids have common names. Formic acid is the one-carbon carboxylic acid. So it's just a carbonyl group directly bonded to a hydrogen on one side and the OH group on the other side. This structure is commonly called formic acid. That's the most typical name that is used for it. In the IUPAC system, we would refer to this molecule instead as methanoic acid. Methan referring to the fact that there's one carbon, oic acid referring to the fact that it is a carboxylic acid. So it would be perfectly acceptable to call this methanoic acid, but most commonly it's referred to as formic acid. You may have heard the term formic acid before because this is the compound that is present in the ant venom. So when an ant stings you, a fire ant in particular, the reason why that sting feels unpleasant and perhaps swells up is because of the body's reaction to formic acid. Acetic acid, by adding one carbon to the chain, we changed the properties of this molecule quite a lot to take it from ant venom to being the common component that is active in vinegar. This is what vinegar gives its sour taste. The IUPAC name of vinegar's active component, acetic acid, would be ethanoic acid. But generally, if you're looking at an ingredient label for a substance, it will say acetic acid rather than ethanoic acid because of the fact that that name acetic acid has very, very much stuck over time. Propionoic acid, the prop there would suggest to us 3 carbons, and this is indeed the common name, the old school name for a 3-carbon carboxylic acid. The IUPAC name for this molecule will be propan, referring to the fact that there's 3 carbon atoms, oic acid. So in this case, the common name propionic acid is pretty similar to the IUPAC name for this molecule. And then butyric acid, the but there suggests 4 carbons, and indeed that would be correct. That butyric acid has a 4-carbon chain in total, like so. And the IUPAC name that would go along with that would be just butanoic acid. Butyric acid or butanoic acid is the carboxylic acid that is found in sweat and also a common component of some cheeses as well as butters. Let's take a look at some additional common names of molecules going beyond just these straight chain carboxylic acid molecules. So if we take these common carboxylic acids and we convert them into their salt form by removing the proton from the OH group, we can name these analogously to how we in the IUPAC system change the oic acid part of the name to O8. Here, we're going to change from formic acid to sodium formate. And so the structure of sodium formate, the ATE there denoting that in combination with the metal listed that this is a carboxylic acid salt, refers to the fact that oxygen has lost a proton and that's been replaced with the sodium cation that we list here. If we'd called this lithium formate, we would have instead had a lithium counterion here. The form part refers to the fact that there's just one carbon in this chain of this carboxylate salt. Sodium acetate, similarly, will have a sodium directly bonded to an oxygen, followed by our carbonyl group, and then followed by a methyl group to make a 2-carbon chain, hence the so-called acetate group, a 2-carbon chain with a carbonyl group, and that's going to be bonded to our ONA group because the hydrogen from acetic acid has been replaced with the sodium. This is a common component that's used in the isolation of DNA to help precipitate DNA during the course of isolating DNA in a variety of biological experiments and other applications as well. So carrying on here, if we had propionic acid and we replaced the hydrogen here with a sodium or other metal, the molecule would become something like sodium propionate. So that ATE ending in combination with the name of a cation is going to denote a carboxylate salt. Now let's take a look at some esters that we can name using common names as well. The acetate name comes up commonly, and if we pair the acetate name, which refers to our 2-carbon chain, starting with a carbonyl as it did in acetic acid and sodium acetate, in ethyl acetate, rather than having an oxygen bonded to a cation, instead we have the oxygen bonded to an ethyl group. That's why it's called ethyl acetate. So ethyl acetate is going to be an ester where we have our 2-carbon chain, the ethyl part of the name, bonded to the acetate group, that is our carbonyl group, directly bonded to one other carbon atom. So acetate in each of these cases, or acetic in the case of the acid, is referring to a carbonyl group directly bonded to a methyl group in each of those cases of applying this toward a variety of common names. We could also talk about a compound called methyl acetate, which would be with the acetate group, but over here, directly bonded to the oxygen, would just be a methyl group, a 1-carbon chain instead of a 2-carbon chain there, causing it to be referred to as acetate. Now, as we continue onward here, let's look at molecules that have the salicylate or salicylic name in them, which we've alluded to before and mentioned before as molecules that are important flavors and fragrances and have analgesic properties and a variety of other commonly now and also historically applied functions. We'll start here with salicylic acid, which is an aromatic ring directly bonded to our COOH group, our carboxylate group, hence why this has the name acid. And then at the ortho position, one spot over, we have a hydroxy group. So this structure altogether is referred to as salicylic acid. Now, if instead we're referring to sodium salicylate, we'll notice that the change in the name is that we've brought in a counter ion, sodium, and we've changed the suffix to ATE. That combination of terms, that is a cation at the beginning and ate at the end, indicates a carboxylate salt. And so, thinking of sodium salicylate, a carboxylate salt, what we need to do is take the starting material that was salicylic acid, and we are going to be working on that COH group and converting that, instead of being COH, it's going to be COO minus with a sodium counter ion there. And we don't have to put O minus and Na plus. We could if we wanted to, but putting just O and A implies that that's an oxygen anion and a sodium cation, and that's sodium. And then salicylate is referring to the rest of this molecule, which is an ion because of the negative charge on that oxygen that would have to be present. And then the next molecule, the related molecule, methyl salicylate, this molecule shown here that I'm drawing out now, is going to be represented by having COO directly bonded to a methyl group, which I'll put CH3 out here to emphasize that for us, that methyl salicylate, the methyl group, is referring to what's bonded to the oxygen, much like up here when we're naming ethyl acetate or other esters, even using the IUPAC system. We named at the beginning of the name the alkyl group that's directly bonded to the oxygen, hence methyl in this case, and then salicylate refers to the rest of the molecule. And that's all from the parent name salicylic acid, a common anti-acne treatment and facial exfoliant that has, in the case of the carboxylate salt, lost the hydrogen atom and it's been replaced with a sodium or other metal, or replacement of the hydrogen atom with an alkyl group to refer to it then as an ester, hence having an alkyl group name at the front, such as methyl, and then at the back end of the name, salicylate, with the ATE ending there in salicylate being paired with an alkyl group name at the front tells us that this molecule is an ester. It can sometimes be a little confusing to distinguish between carboxylate salts and esters because the names will look similar. They both end in ATE. The way to tell them apart in both IUPAC and common nomenclature system is that in the case of a salt, since the salt by definition has an anion and cation, it's going to begin with the name of a metal. On the other hand, an ester is going to begin with the name of an alkyl group by definition. So with these structures in mind, you should be able to recognize and apply these common names towards solving problems related to reactions, physical properties, and other roles that these types of molecules play.